Hello, students. Our today's topic of discussion is integration. So, as we all know, integration is a subject for class 12th. So, today we shall start with some basic theorems of integration. Okay. So, now here in this book, I've taken some basic book for the explanation of this integration. So, let's see. Here we have two functions, fx and gx, and in which variable is x obviously. So now when we integrate any function, here the function is fx and the k is constant, so we always take the k outside the integration. Okay, so here you can easily see k is outside the integration and the function is there fx, which we want to integrate with respect to x. Now in the next case, when two functions are given and either they are add up or in subtraction, so we can separately integrate those functions if they are either adding or in subtraction. Now let's move on to the next. You always know differentiation and integration is inverse processes of each other. So whenever there is a differentiation of any integrated function, so we always find that function, and differentiation will make neutral the integration. So we are left with the function only. So in the next fourth case, we have integration of a function which is already being differentiated. So when we take that, integration sign will make neutral with this differentiation sign, and we are left with the function only, which is fx. So let's move on to some standard integrals. So in the standard integrals, we have like x here, and it has some power like alpha, and we want to integrate this x to the power alpha with respect to x. So how can we integrate that? So when we integrate that, its power is going to be increased by 1, and that power is comes under the denominator. So it is increased by 1, very important, and it is used for mainly for exponent functions. So while in case of derivative the power is reduced by 1, but in case of integral it is getting increased by 1, and we make the division by the same exponent. Plus c is the integration constant here. Whenever we do the indefinite integral of any function, here function is x to the power alpha, so we always write c, which is nothing but constant, or we may call it as integration constant or any arbitrary constant. So here in the second question, when we take the integration of 1 by x, so we find out our integration as, after integration we have natural log of mod of x plus c, where c is nothing but our integration constant. Similarly, when we integrate sin x, we find minus cos x plus c, and when we integrate cos x, we find out sin x plus c, where c is again the arbitrary constant. Now what if we find out the tan x? So which function we should integrate? So we have to integrate sec square x or 1 by cos square x. So we find out tan x, because tan x has a derivative which is called 1 by cos square x or sec square x. Similarly, for other trigonometric function, 1 by sin square x means cosec square x is again the minus cot x plus c. So when you know the derivative of the respective function, you can easily calculate the integration. If the derivative exists of the function, then there is always a integration of that function, because derivative and integration is inverse processes of each other. Now in the next case, 10x integration of 10x dx is nothing but minus natural log cos x plus c. Similarly, in the 8th case, integration of cot x dx is nothing but ln sin x plus c. This is important one should remember this. Now when you integrate ex, you find ex. When you differentiate ex, you find ex. So ex has the same value always when you integrate it. So when you integrate a to the power x, this is important one. So you can use the substitution method also in this case to integrate this. So you'll always find, you don't need to remember this, but if you want to, so you can use, which we further discuss in the next sections of integration, where you can easily find out the integration of such functions. Now in the 11th identity, when you integrate 1 by 1 plus x square, so you find out tan inverse x plus c, where c is again the arbitrary constant. Similarly, for other functions, when you integrate 1 by a square minus x square, so you'll find out this expression, which is 1 by 2a ln a plus x by a minus x. Again, in the 14th identity, when you integrate 1 by square root 1 minus x square, so you will find out sine inverse x. This is important one, and it is used in most of the examples, or you can say questions. So in the 15th question, integration of 1 by square root a square minus x square is again here it was 1. Now instead of 1, here we have a, so we can put here upon a, so the answer will remain same. We just substitute 1 with a. Similarly here also, in this case, square root of x square plus minus a square, important one. So you'll always find natural log of x plus square root x square plus minus a square plus c, where c is an arbitrary constant. So that's it for this video. We have numerous number of integration for many more functions, which we discuss in the later video, but for now, one must always try to understand the basis of integration. How does this integration came from? So there is some graphical interpretation of the integration also, which we discuss in the later sections, but for now we are stick ourselves to the formula, how we actually solve the mathematical formulas in mainly CBSE questions or some CBSE level examinations, or you can say competitive examinations. Thank you.